Thank you, David, for that great presentation. And now we're gonna move on to lift station rehabilitation design and what should be taken into consideration and the challenges that you may run into during design. So first of all, lift station, like any other components of your collection system, will need at some point to be repaired, evaluated, rehabilitated, like manhole, sewers, force main that um, David was mentioning before. So what is the anticipated life cycle for your lift station? So according to the industry standards, your mechanical components will probably last about 20 years. And then for your wet wells, it will depend mainly on on the type of construction, the material of construction. So if you have a steel wet well, it will probably last about 25 years, and a concrete wet well will probably last around 50 years. So what's the consideration for replacement and rehabilitation? So like I just said before, the age of lift station is one of the main one. Then you need to consider if you have breaks and all the overall maintenance cost. You need to look at flow capacity improvement. Remember that the goal is to match pump capacity, type, and configuration with wastewater quality and quantity. Um, you need to look at the number of overflows. Obviously, you want to avoid flooding of the lift station and the surrounding areas. You need to consider if you would like to add backup powers, an automatic transfer switch. Maybe you don't have that yet at your lift station. You need to also consider difficulty to repair and access your lift station. You always want to allow for easy operation and maintenance of the installed equipment. And also odor issue. This is also a critical one. You want to avoid septic condition and excessive release of odors in the collection system and at the lift station itself. You need to consider flow measurement. Suitable devices should be installed in your lift station to measure the flow. And finally, the emergency pumping capability. Well, like David was mentioning, you probably want to have like a backup solution with, for example, like a portable pump that you could connect to your force main directly. So what are the challenges? I think the main thing is to actually understand your project. You want to know it's going to be like a new lift station, an upgrade, a retrofit. You want to look at the present and the future condition to accommodate potential future expansion. Um, and obviously, analyzing the existing condition is critical part of this. So anything you can gather, the record drawing, specification of the original design, the manufacturer design pump data sheets are also critical. And then you need to assess the reality of what you have in front of you. So a thorough assessment of the lift station like David developed before. All of this to what? For what? To evaluate all the alternatives and determine the best fit for each application. Do you need a dry pit, submersible, suction lift? I mean, this is the critical part. And the trend we see lately is that we actually replacing the dry pit lift station with submersible lift station for small to medium lift station just because of a smaller footprint, lower cost overall, and a simplified operation and maintenance. And then last but not least, another critical point is to identify all the constraints during construction. The main one is bypass pumping. What do you want to do when you're actually going to rehabilitate the lift station? Are you going to reuse your lift station you're having, or are you going to need another temporary bypass pumping? Dewatering, site conflicts. Obviously, if you want to dig and install a new wet well, you're going to have to look at that. And finally, another critical point is the coordination with local businesses and residents. You want to minimize as much as possible the environmental and landscape impacts for the on the surrounding residential and commercial areas. So I'm gonna develop a few examples that RGN has designed in the past. The first one is the Villa Park lift station. You can see on the picture the very advanced corrosion of the wet well, a steel wet well, and the piping. So this was replaced with a fiberglass wet well. It was a small size lift station, about 300 gallon per minute. So we installed like new 5 horsepower submersible pumps, a 30 kilowatt gas generator, and a new control panel. The second lift station I'm going to mention here is the Elmhurst lift station, Park Avenue lift station. So this one is a little bit different. We actually reused the existing, it was a dry pit lift station, so we removed the dry pit and install submersible pumps. And at the same time, we equipped the lift station with a new prefabricated building that includes a PLC, a SCADA system, 30 kilowatt generator as well, and also a couple of other features like new valve vault, and also there was a bypass connect vault as well. The last lift station is a bigger lift station, about 5 to 6 thousand gallon per minute capacity. So this one was a complete retrofit of the lift station with restoration of the building. We added a new wet well about like 30 feet deep, casting place, 3 submersible pumps for wet weather, sorry, and 2 submersible pumps for dry weather. A new standby generator in the existing building, like 500 kilowatt generator, a big generator, and also all the nice landscaping around the lift station. So that's it for me. I'm going to take it over to Mike Stone.